All right, in this lesson, we're going to start adding an enemy into our Godot game. So of course, we'll start off then by doing a quick overview of our enemy file inside of Blender before exporting it to a GLTF file and then bringing it into Godot, of course. And in this lesson, we'll begin programming our game enemy's behavior, including his movement and wall detection. So he'll be able to move back and forth in a game level between two walls, turning around and moving in the next direction when he collides with a wall. Let's go ahead and jump in. The first thing I'll do is I'll switch on over into Blender, because this is where, of course, I have my little gumdrop enemy. If I go ahead and show you the overlays, including my gizmo and the grid and the bones that control my enemies, a lot like my game character, this is a simple mesh object, my character is, with a few bones, many fewer than my game character though. This enemy has only 2 animations in the nonlinear animation editor, including a little animation, which I'll go ahead and activate, called Blob. And Blob simply is this little enemy's movement, which is simply moving up and down, squashing and unsquashing as he's walking along or sliding along the game level floor. And we also have, when you jump on the enemy and squash the enemy will get squashed. So you can see here this animation, which I actually haven't given a name to, actually. I'm not quite sure why. Oh, there it is, called squash. If I enable it, you can see that it starts off with the enemy at a normal height, and then after just a few frames, the enemy becomes squashed. So we have a blob animation for movement and a squash animation. Just a note that because I modeled this enemy very simply, I'll go into edit mode with the tab key, of course. I used the knife tool to create the eyes, and therefore the eyes might cause us a little bit of an issue inside of Godot. Just a warning that when you model in Blender, you can have what are called n-gons. N-gons are polygons that are uniquely or awkwardly shaped, that have more than 4 sides. Game engines don't always like this sort of topology. In Blender, you can get away with it. In Godot, we might see it work well or not, because the faces that have more than 4 sides need to get divided into triangles, and therefore they might appear a little bit different and bend a little bit differently inside of Godot. You've been warned. Okay, let's go ahead and zoom out and go back into object mode. I'm going to go up to File and export a GLTF file. I'm going to leave everything at its default, but here on my desktop, I have my project folder. In my project folder, I have, of course, my assets folder, and in there I have my models folder, which is where I exported the GLTF file of my robot character, the blocks, the coin, they're all here. So I'll go ahead and export a GLB file called enemy.glb, and I'll press export GLTF. My mouse cursor will change to a little count up timer, I think, showing me how many seconds have elapsed while it's exporting. If you have a faster computer, your mouse cursor might just blip a little bit like mine did. Although if you have a slower computer, you might see your mouse cursor change to a little black rectangle with numbers counting up on it for a few seconds, depending on your specific file. But let's go ahead and save this Blender file and go back into Godot, where of course I have my game level with my character and everything else we've added so far in our game project. What I'm going to do now is go over to my file system doc, where I have my models folder here, and you can see that the enemy GLB file has been imported successfully. So what I'll do actually is right click right on it and say new inherited scene. I'm not going to make the enemy GLB file directly into a new scene by saving this new inherited scene. Instead, I'm going to just go into the scene exactly pretty much like I went into my robot scene, and I'm going to copy the resources or the nodes out of the scene into my own new scene, because I like making my own scene for game objects and not relying on an imported file. So I'm going to open by right-clicking on enemy.glb, a new inherited scene based on that file. here's my little enemy. Although you can see in the scene doc that the enemy itself is referring to another scene. This is the problem that I don't like. So I'm going to go into that other scene that this is an instance of. So we'll click on this little icon and it's going to let me choose open anyway. I'm going to open the original scene by clicking on open anyways, and then you can see now that I have two tabs open. In the second tab with the original scene, I can copy the bottom 4 nodes. I don't need 2 node 3Ds, these red circles here. So I'll just select armature all the way down to animation player, and I'll right click on those with them selected and I'll copy them. Okay, so now I can go and make my own enemy scene. I'll press this little plus here to do that. And to start off this scene, I need to make my own root node, which needs to be, believe it or not, a character body 3D, just like my main character, my robot character. Whenever you make an object in Godot, that's going to be a 3D character-like object that you want to program the movement of, you typically want to use a character body 3D. So under node 3D, under collision object 3D, and under physics body 3D, character body 3D, or I could find it in my recents or search for it. I'll go ahead and double click to make that my root node. Now I can go ahead and paste those nodes that I just copied a moment ago. So I'll right click on my root node and say paste. There we go. We have the character, the enemy in this scene. I'm going to go ahead and name the root node enemy with a capital E, and I'll press enter, and I'll save this scene, Control S, into my project folder as enemy.tscn. There we go. I can now go ahead and close these other 2 scenes that I just copied from. So I'll go ahead and close that without saving. There we go. Our enemy scene has an enemy in it, although I think, and it's hard to tell here, I think it's too big. If I go ahead to my level 1 scene, and I could add the enemy directly as a child of the root node, but instead, like my blocks and like my coins, I should probably, because I'm going to have many enemies in my scene, make a folder. So of course, I'll select my level 1 root node, I'll press plus, I'm going to add a simple node 3D to act as the folder or parent for all of my enemies. So I'll add a node 3D and I'll name it enemies, like that. And then with that node selected, I'll press the create instance or instantiate child scene, the link button, to bring in my enemy dot, not the GLB file. It is recognized as a scene, but make sure you select the one that you set up properly, enemy.tscn. So there it is, enemy.tscn. I'll press open. I have an enemy in my scene. However, you can see it's gigantic. I don't need my enemy to be that big. So back in my enemy scene, I'm going to select not the skeleton or the cube. I forgot to rename the mesh in Blender. That's why it's called cube. Instead, I'll select the armature and scale that. So with the armature node 3D selected, I'll go over to my inspector and transform, and I'll change the scale. I'm going to make it quite a bit smaller. I'm going to change the scale to 0.3, 30% of the original size. And because all 3 scale values are linked, you only have to change one to change them all. So I've got my little enemy. What I should probably do is select that armature and move the enemy down so that, I'll go ahead and turn off my snapping here, so that the enemy is in the middle of the world. I think in Blender, I might have moved the enemy over a little bit. So if I select that armature and go to the transform position properties, you can see that on the X and Z axes, it's not centered. So I'll type in 0, tab a couple times and press 0 and enter to center him a little bit better. Our enemy has a warning here. If I click on the warning, you should know what it's going to say. It says this node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 3D or collision polygon 3D as a child to define its shape. You should know what this means. It means that when you have a physical object, a physics object, you need to give it a collision shape. What I'm going to do is select my root node and press plus. I'm going to add one of those from my recent collision shape 3Ds right there. Of course, you can search for it, and I'll go ahead and double click to add it into my scene. You might wonder what shape you should use, but I'm going to strongly suggest for your collision shapes shape that you use something with a rounded bottom on it. It could either be a capsule, but I'm actually going to recommend a sphere. So I'm going to make a sphere shape 3D. You can see that if I unselect it, it's basically a wire ball, but I'm going to make it kind of small, kind of matching his width. And I'll go and look through, I'll click on this little Z direction there on my screen so I can see exactly how wide that blue sphere is. And I'll make it a little bit narrower than him, and I'll move it up so that the bottom of the sphere just touches where I want him to land. I don't mind that it's not going all the way up to the top of his head here. That's okay. In fact, you'll see why in the next lesson. But I think that's good, so I'll press Control S to save. If I go back to level 1 and position my enemy somewhere a little more appropriate. Now, I'm going to make my enemy go back and forth between two walls. So if you don't have an appropriate location where there's a wall on both sides, I would suggest that you select your grid map and a tile and just make an area of your floor that has a wall on both sides like me. Even if they're just a short little wall like this, that's fine. I'll take my enemy and move him up, and you'll notice that even though he's above the ground, that's okay with me because our little enemy is going to have gravity pushing down on him, which we'll have to program right about now. Just to show you though, if I save this scene and press play scene, the enemy just floats there. And do we bump into him? No. That's actually a good thing, but it means we haven't set something up yet. If I go back into my enemy's scene up here, you'll notice that with the root node selected, I haven't changed my collision layers and collision masks. Please recall that whenever you add objects that are physical objects that you might interact with in any way in your game, you need to set these up. Of course, I named my layers in an earlier lesson in this course. So layer 4 here is my enemy layer. If I hover my mouse over that long enough, you'll see a little pop-up show up that says enemy and the name of that layer, item, ground, and player. I'll put the enemy, its root node, on layer 4 and turn off layer 1. And the enemy needs to touch the ground only, like that. You might think the enemy would need to detect the player, and that's true. Although in the next lesson, we're going to make a separate area in our enemy that will have its own collision layer. So for now, that sphere that is its collision shape will only know about the ground and not the player. Okay, so I think that looks good. I'll do a Control S to save. If I play my level again, you should see that I'll bump into my... There it is, the enemy. I don't actually want that. I want a different part of the enemy to touch the robot in the next lesson. So what I need to do here is I actually set up my characters, my robots, collision layers and masks not quite properly in an earlier lesson. So I'll go into Steve's scene. Make sure you do this inside of Steve's scene and not just on the instance of scene right here. In Steve's scene, on the root node, I have a mask turned on for the enemy, and I should turn that off. Layer 4, the enemy layer, I don't want the player to be able to collide with the enemies. Okay, so I'll turn that off. I'll do a Control S to save, and back in level 1, I'll go ahead and press play scene. And so now you'll see I've got my little enemy and I can walk right through it. Great. We need to program our enemy for movement, and that's going to involve some new code in this lesson. So I'll go ahead into my enemy scene, and on the root node of the enemy, I will add a new script. Make sure when you're adding a script to the root node of the enemy that it says character body 3D. And even though we're not going to make our enemy be controlled with arrow keys on the keyboard, we're still going to use this template for our code called basic movement. This is how we started off our game character that we control. variable. This code gives us arrow key control. It has a few other pieces though that we'll like to have that will make coding our enemy a little bit easier. So don't change it to default or empty. Okay, everything else here looks good. Enemy.gd is a good file name, so I'll press create. What I should do with this code is, I'll go ahead and maximize my workspace, is get rid of the things that I don't need. You'll see up here on line 4 that I have a speed. Does my enemy move with a speed? Yes, it will. So I'll keep that. However, my enemy will not be jumping. I'm not going to control my enemies jumping with the spacebar on my keyboard. That's for my robot. So I'll get rid of jump velocity, that constant entirely. I'll press delete. Because my enemy is not going to jump, and I've gotten rid of that variable, I don't need to have this section of code in physics process delta called handle jump and pressing the spacebar and all that, so I can get rid of that section. In fact, in this physics process delta function, I don't need to have any of the movement control for arrow keys. I do need this move and slide at the bottom because that's how you make a character body move. I do need to see if the character is not on the floor and therefore they would fall down with gravity. That's the gravity code. I'll leave that, but I'll get rid of that movement code, leaving move and slide at the bottom. There we go. So what happens now? Just a note that I'm also leaving my variable gravity, which goes into my project settings and gets the 3D gravity setting that applies to all the other objects in my game, including Steve the robot and my blocks and everything else. So this is the code that I'll start with. I'll press Control S to save. I'll go back to level 1 and I'll press play scene. So now you should see, hopefully, my little enemy over here fell and landed on the ground, which is great. How this enemy is going to work is I'm going to rotate him in my game editor in the direction that he's going to move. In other words, I'll go ahead and select that enemy and I'll use my rotate gizmo with just my arrow tool selected up here. And if I hold Control on my keyboard and grab the green hula hoop here, I can rotate. Depending on if you have snapping turned on or off, I'll turn it off. You should be able to rotate with the Control key to make it snap to 15-degree increments. You should also see down here how many degrees you rotated. And so if my character was facing to the right and I want him to face to the left, I can hold Control and rotate exactly 180 degrees, which I did just then, just like that. And there we go. I might move the character back a little bit, and so he'll move in this direction. How do I get him to move? Well, in his code, I'll go ahead and bring his code back up, and I'll maximize the script workspace. What I need to do here is give him a direction variable. So right here, I'm going to make a variable called direction, and because he could be moving in either the x-axis horizontally or the z-axis horizontally, I could make a direction variable for each of those, like direction x and direction z. Recall that the y direction is just up and down with gravity. So what we could do is use a vector2, although I think we'll use a vector3 variable. I'll put a colon and an equal sign to use static typing, and I'll make a vector3 variable. And I'm going to make this direction variable not have just 0, 0, and 0 for x, y, and z values by default, because I know that I want this enemy to, if I go back into my 3D workspace, I want him to move on the positive x-axis direction because I can see my little gizmo here pointing on the red axis, which is x, in that direction. That means that that is positive x. So I'm going to use this direction variable in my enemy's code to represent which direction, not how fast, not the speed in which to move, but I'm going to make each value, x or z, be either a -1 or +1 for the negative or positive direction in that axis, or a 0 for not any movement on that axis at all. So what I'll do here is I will make, because my little enemy is going to move on the positive x-axis, I'm going to use in that variable just a 1 here in the x value. Okay, the next thing I'll do is I will go into my physics process delta, because 60 times per second, I need to tell my enemy's velocity. Recall that every character body 3D object has a built-in variable called velocity, which move and slide uses to actually move your character in 3 directions. Velocity is also a vector 3. The move and slide method, using that velocity vector 3, tells your character how fast and in which directions to move. What I'm going to do is 60 times per second, I'm going to add to the very top of this physics process delta function here. I'm going to say I want to make my velocity dot x equal to speed, but multiplied by either 1 or -1 from the direction values corresponding with the x-axis and the z-axis. We'll do one line for each. So I'm going to say times speed times direction dot x. So if vector 3's x value is 1, on the x-axis, we'll be moving our character 5 times 1. If this is a negative value, we'll be moving our velocity.x enemy here 5 times -1, which is -5 in the opposite direction. So hopefully you can see that flipping these values back and forth between 1, -1, or 0, we can control using speed, our velocity.x, and I'll copy this line, Control C, and on the next line I'll paste it. I'll use velocity.z here for the next line, like that. So if I go ahead and save, and I go back to level 1, and I press play scene, is anything going to happen? Yeah, you can see the enemy went over to the side here and has stopped at a wall. Do I want my enemy to move at a speed of 5? Well, I can try a lower number. I can try 3. Let's see how that looks. And like that. And if I move him over, let's say I move him just temporarily over to here. Does that work? A little bit over there. And I press play scene. You'll see he's moving in that direction. We'll work on him facing the right direction in a little bit later in this video. That's fine. So I'll move him back over to where I want him over there. In fact, why is he moving to the right when this is the positive x direction? I have it in my code for him to move. Did I change it to -1? I did. +1 is for positive x, so I changed it just to show you, but then I forgot that I did. So if I go ahead and press play scene with my level 1 tab active, he now moves in the correct direction for the way that he's facing. If I want him to move to the right, what I would do is I would go back to the scene. I would rotate him with the control key held down to face in that direction. And then I would make sure that I change that value in his script to be -1. However, every enemy in my game level, and I'm going to have more than one, is going to have the same script file. So do I want to have every enemy go to the right when that level loads up? No, I don't. So I'm going to make this variable exported. And you've seen that in an earlier lesson. It might have been the last lesson in this course. What you do is you put the annotation with an @ symbol with the word export before the variable, just like I have. And then if you go to your scene and you select that enemy, in fact, I'll name this enemy enemy 1, you can see that direction variable is up here in my inspector. And so for each enemy, I can type in a value 1, -1, or 0. Of course, I could type something else, but I wouldn't do that because I know what they're for. And then that enemy will move in that direction, and I can rotate each enemy the way that I want them to go. Okay, so I think the next step here is to detect if my enemy is touching a wall. So I'm going to go back into my enemy script and I'll maximize my scripting workspace. What I'm going to do is below move and slide, because I want to make sure that my character or the enemy has had a chance to be told how fast and in which direction to move. I want to make sure they are falling with gravity if they need to. I want to actually move them on the screen or in my 3D world using move and slide. And then I'll press enter a few times, but still in physics process delta. Then I'm going to check to see if they're on a wall. So I'm going to write an if statement here, and I'm going to call that method if is on wall. I'll use my down arrow key and select that method call and put a colon. If I'm on a wall, what should I do? Well, the first thing we'll do here is we're going to change our direction. Right now, if I'm heading to the left with -1 on the x-axis, I'm going to flip that over to +1. So what I'm going to do here is say, make the direction dot x equal to itself direction dot x times -1. Why times -1? Well, what we want to do is make the direction equal to the opposite of it. If direction.x is already 1, and we want to make it into -1, what's 1 times -1? It's -1. That works. 1 turned into -1 is what we want. What if direction.x is already -1? What's -1 times -1? It's 1. So -1 becomes 1, and then becomes assigned back into itself. So this line of code should work. It's kind of tricky and a nice use of -1 to multiply, to switch it back and forth between 1 and -1. Hopefully you understand that. What I'll do is I'll copy that line of code because we need to do the same exact thing for the z-axis as well. So I'll type in z and z. In fact, some of you might be aware that you can simply type direction.z times equals -1. Times equals means make the variable on the left equal to itself multiplied by another number here. These two lines mean the same thing except for the x and z axis. You can do both the same, or like I've done, you can do one of each. What I'll do now is I'll save and I'll go back to level 1 and I'll press play scene. Does that work if I look at my little enemy? He's bouncing back and forth between the two walls. That looks pretty good. But what I want to do here is I want him to pause for a moment to give him time to, as he's paused, as he's stopped at a wall, to rotate and turn around so he's facing in the other direction before he starts moving again. This makes things a little bit more complicated than just going back and forth like this. We're going to use some new code in this lesson called an await and creating a timer in script to make our little character wait while he's at a wall to give him time to turn around. And in this lesson, we're going to use what's called a tween to make our little character rotate. Tweening is like making animation with code, where you would have keyframes in an animation. You can code those. It makes it much, much simpler and in only 1 or 2 lines of script. So let's go ahead and add that. What I'm going to do is say when I'm on a wall, if I'm on a wall, I'm actually not going to put all of my code for him turning around right here. Instead, what I'm going to do, I'll zoom in once or twice to make this bigger on my screen, is I'm going to make a function called here. So I'll press enter. And on this line, I'm going to call a function that I'm going to write called turn around, like that. When you're calling a method, you have to put round brackets, parentheses, of course. And then what I'll do is I'll press enter a few times and backspace. And at the very beginning of the line, so no longer are we in function physics process delta, at the very beginning of the line, I'm going to make a new function called turn around. Like that, with a colon at the end of the line after the parentheses. I'm too indented here, so I'll select those lines and I'll press Shift Tab. Shift Tab will outdent, Tab, of course, indents, Shift Tab, outdents. We need to have it just 1 tab in to make it all line up, or 1 tab after the colon from the beginning of the line, of course. So what I want to do here is I'm going to set the direction to equal itself on the x and y axis times -1, but that's actually going to be the last thing I'm going to do. Before that, what I'm going to do is make a backup of my direction, because I need my character to stop. And 60 times per second, I'm telling my character's or my enemy's velocity to use that direction, which might be 1, -1, or 0. I want to resume that direction, but flipped using this code. But for a little while, I want my character to stop. So what I need to do is make my direction equal to, I'm going to make a new vector 3 set to 0, 0, 0. However, what I need to do is make a backup of this direction in a separate variable so I can use it again to go in the opposite direction after I've paused and rotated. Hopefully you follow. So I'm going to go ahead before I set my direction to equal to 0 is I'm going to make a variable right inside of this turnaround function called just dir for a backup direction. And I'm going to make it equal to direction like that. Okay, so I've made a backup of direction. I've set the actual direction to 0. Now I need to pause my enemy before doing these 2 lines of code. This line will have my character or the enemy stop in place. I need to wait. How do I do that? It turns out there's a keyword in GDScript and it's new to Godot 4. This would not have worked with Godot 3.5 and any variation of that or earlier. It's called await. And the way await works is it basically stops your code right at that line in that function and doesn't let it continue until something happens. And typically the thing that you're waiting for to happen is a signal. Now, what we're going to do here is actually create a timer. And a timer is in Godot a node that you can add into a scene. But in this case, we're going to make a timer using simply GDScript right in this same line of code. So what I'm going to do is I'm going to say get underscore tree, which is going to get our whole project. And when you select your whole project with this get tree, you can call a method called create timer. And so I'm going to call that get tree parentheses dot create timer. And this timer needs to know how long it should count down for from a number of seconds down to 0. I'm going to say 0.6 seconds. It's going to start at 0.6 seconds and it's going to count down to 0. And when that timer runs out, it has a signal built into it. I hope you're following. It has a signal built into it called timeout. And when that signal is emitted, we can stop waiting for this line and keep going with our code. So I'm going to say dot timeout like that. Hopefully you follow. What else do we need? Well, let's see what we have so far. I'll press Control S to save. With my level 1 tab active, I'll press play scene. And does my little enemy go in the other direction? Well, no, he stopped at a wall and it looks like we have a problem here. What's going on here? Well, this actually might be a bug in Godot, and I think I've experienced a little bit of that when it comes to this lesson and what we're doing here. Although I think what I'm going to do here is make a Boolean variable so my enemy knows when he should be turning and when he is just moving back and forth. I don't think that this is on wall is working quite as it should. So what I'm going to do here is up at the very top of my code, I'm going to make another variable called turning. It's going to be a Boolean variable, so I'm going to make it statically assigned to the value false to start, because when the game first starts, he's not going to be in the middle of turning around. However, if he's on a wall, I want to call this turnaround function only if he's not already turning. I think what's happening is he's getting stuck on a wall and it keeps detecting that he's on a wall and it keeps calling turn around again and again and again, and it keeps making new timers and making me wait for it to count down. So what I'm going to do here is say he can only turn around if he's not already turning when he touches a wall. So I need to say if he's on a wall and he's not turning. Remember that turning is either true or false. And so if we say not turning, it needs to be a false value, not true. So we're using the not keyword here to our advantage. What I'm going to do now is if he is turning, if this function is running turn around, I'm going to set turning to equal to true. But then when this function is done, I'm going to make turning equal to false. Hopefully you can see why we're doing this. It's because isOnWall is calling turnaround in successive 60th of a frame, again and again frames of my game. We don't want that to happen. We only want to call turnaround once to start this process happening. Okay, let's see what happens. I'll press Control S to save. I'll press play scene. Actually, with that backup variable that we made a few moments ago called dir for our direction, we need to actually use that backup at this point to reinstate the opposite direction of the direction that we saved at the bottom of this function that we've just made. So after telling our enemy that he is turning around, that is true, and after making a backup of the direction, and then setting the direction to equal 0 to stop him from moving, and then getting the tree of our project and creating a new timer and waiting for it to time out using this await keyword, we need to then take the direction that we had originally for our character and flip it and reassign it to our direction. These two lines don't do that. They were just making the direction flip before we had a backup dir variable. So what I'm going to do here is say on line 33 and 34 in my code, I'm going to say make the direction.x equal to the backup of my direction, which is just dir, but inverted using a multiply -1. So I actually can't use the shorter version of my code. I actually need to write it out without the shorter multiply equal operator. So I'm going to say direction.z equals dir.z times -1, like that. Okay, so I'll press Control S to save. And you know what? I've forgotten to change this X to a Z. We should have an X and an X on this line and a Z on this line. That looks good. I'll save and I'll press play scene. And so now I should be able to see my little guy going back and forth here, left and right, left and right. We are almost there. The last step for this enemy, I believe, is to make him turn around in the direction that he's looking every time he hits a wall and then pauses. We then want him to turn. To do this, we're going to use what's called a tween. A tween in Godot is essentially you programming with code 2 keyframes of animation. If you want to animate your character moving its position from point A to point B, well, if you were to animate this, you would make 2 keyframes and the computer would fill in all the frames in between. Now, all the latest versions of Godot, I believe 3.5, but especially 4 and higher, have a type of data called a tween that you can make a variable out of. In my code, right above this await line, which by the way is meant to give us time to be able to actually do this tween in the first place, right above this line of code, I'm going to make a new variable on a new line called var turn tween. And to initialize this variable, we're going to make it equal to a method call called create_tween. Just like that, with 2 parentheses at the end of that line, of course. So this line of code, it makes a new tween. On the next line, we need to actually use this tween to tween a property in the inspector of our enemy, which in this case is going to be its rotation in degrees. Turn_tween, this is our tween variable that I can call a method from by putting a dot, and then I'll call the method called tween_property. You can take a tween, your variable, and use it to tween a property of the object or pretty much any object in your entire scene. So I'm going to call that method called tweenProperty, and now you can see it's listing for me a list of parameters or arguments that I need to fill in these parentheses. I'll go ahead and maximize my workspace so we can see all of these arguments that I need. The first argument is the object that I want to change a property of. Well, this code is on my enemy, so I'm simply going to say self, just like that, and I'll put a comma right after that. The next parameter is what property do I want to actually tween? This is going to be a name of a property that you would find in the inspector. So if I select my enemy, which is a character body 3D, what property over here in quotes do I want to tween? In this case, I'm going to tween the property called rotation underscore degrees, so I don't have to deal with radians. The next parameter is, right here, I'll put a comma, and now it wants me to type what I want that property to look like at the end of my tween, the final value of that variable. In this case, I want to rotate my little enemy 180 degrees. So I'm going to make a new vector 3 here with parentheses, and I want to rotate the y-axis 180 degrees. So I'm going to type 0, 180, 0, just like that. After that closing bracket right there, I'm going to put one last comma because I need to put the last parameter right there, the duration. The duration is measured in seconds using a float variable. That means a number with a decimal point. So I'm going to say here, well, the same 0.6 seconds. So right there, 0.6, just like that. Now, there's a problem with this one line. We're using our tween that we made to call this method tween property, and we're telling it to, on itself, on the same object that this code is on, to change its property called rotation degrees to be 180 degrees different on the y-axis over 0.6 seconds. However, it'll actually make this rotation degrees property equal to this exact value at the end of that 0.6 seconds, which isn't exactly what we want. We want to rotate our little enemy by 180 degrees, but relative to how he's currently rotated. So if he's already rotated 180 degrees, we want him to end up at 360, not at the end 180. We're going to add to the end of this line a dot because we can modify this line using an asRelative method call. If I add dot asRelative with parentheses, of course, it will not always ensure that this is the actual value at the end. It'll change the rotation degrees that are currently on the enemy by 180 degrees relative to what its rotation degrees already is. Hopefully that makes sense. If I go ahead and press Control S to save with my level 1 scene active, I'll go ahead and press play scene. Let's go ahead and see how this works. And you can see, hopefully, that he is turning around as appropriate. Okay, it looks pretty good. He's missing something though. Do you see it? He's not squashing up and down. I've saved the most simple part of this for last. What I need to do is go into my enemy scene. I'll go ahead and look at him in the 3D workspace. And I need to tell his animation player to have a blob animation auto load. This little button, if you turn it on, it's blue, it's active. It means that it'll play this animation at the very beginning of when your scene first loads. And I'll turn on this loop option so that it'll repeat again and again. And again, that's the little squish up and down animation. If I save that, go back to level 1 and I press play scene, let's check it out. You can see, hopefully, that he's blobbing or bobbing up and down a little bit. Now, I did mention at the start of this lesson that there might be some issues with the animation when it comes to his eyes intersecting or how they're rendered with the body. And you can see just a little bit of that on his left eye on the right of the screen right there. It's kind of being clipped by the body just a little bit. If I'm picky about that, I might fix my animation in Blender and then re-export it to GLTF and then copy and paste those same nodes back into my enemy scene and then turn on the auto load and loop options for that animation. So the last step here is to take my one enemy in my game level and duplicate the enemy and make sure that all the directions are correct. So in my scene dock here, I've got enemy 1. I'll right click on it and say duplicate. I'll take enemy 2 and I will just, I believe, move him over a little bit, the copy. I might want this enemy to be facing in the opposite direction. So I might move it over here and then rotate on the y-axis, holding control on my keyboard to snap 180 degrees perfectly like that. And then I might change his direction to be +1 on the x-axis, like that. I might take enemy 2 and duplicate him. I might move that copy, enemy 3, over here, and then I might rotate him 90 degrees like that. And now I want to make sure that he's not going to move on the x-axis at all. I'll turn this x value to 0. I want him to move on the positive z-axis with 1 there. And I'll keep going here, but I'll speed this next little part of the video up. Okay, so I've got more enemies in my game level. Let's go ahead and try this scene out. I'll save it. I'll press play scene. And now, as you can see, I've got enemies all over the place. I can spin my little camera around, and I'll go and take a look at how it looks just from a nice little vantage point up here. As you can see, all the enemies look like they're behaving individually, and that looks great. None of them are getting stuck on little edges at all, which is why earlier in this lesson, we made sure that the bottoms of all the enemies have collision shapes that are rounded. I found that with this setup, using a grid map, that sometimes the enemies would get caught on little places here and there, because I believe of the little edges between all of the blocks in the game level. So that's why I decided to use a rounded collision shape for all the enemies. Also, I used a sphere because from the top of the enemies, you would be turning your enemy next to a wall, and I didn't want any of the collision shape to get caught inside any of the wall and detect falsely that the enemy was actually in the wall, and therefore would trigger the isOnWall method to return a false value. So I believe that should be it for this lesson. As always, thank you so much for watching, and I'll see you in the next one. Bye-bye.